I sometimes wonder what the early mammals of Europe must have thought. Imagine them going about their lives when suddenly, from across the sea, arrives a terror bird. Eleutherornis, all the way from South America. It's the only one of its kind ever found outside the Americas. The story of these terror birds, these feathered nightmares, is one of nature filling a void. After the dinosaurs vanished, these birds rose to become apex predators. They dominated for millions of years. It began roughly 53 million years ago, in the early Eocene. The world was a hothouse then, lush forests stretching from pole to pole, teeming with new life after the dinosaur extinction. In this prehistoric paradise, Paleopsilopterus, the first terror bird, appeared. This Brazilian bird stood only about 3 feet tall. Not exactly terrifying at first glance, about the size of a modern stork. But Paleopsilopterus had potential. It possessed agility and speed, traits that its descendants would inherit. It wasn't the apex predator yet, overshadowed by giant crocodiles and snakes, but it heralded what was to come. As the Eocene progressed, terror birds evolved. Nature seemed to have plans for them, and those plans involved getting bigger. Just 3 million years after Paleopsilopterus, Eleutherornis emerged. It was 50% taller than its ancestor, a formidable predator. But size wasn't its only advantage. Eleutherornis also expanded its range like no other terror bird, venturing across the sea to Europe. Fossil remains have been found in France and Switzerland. But Eleutherornis was just the beginning. The terror birds continued to grow, adapt, and diversify. They seemed to be in a competition with themselves, each new species trying to outdo its predecessors in size and ferocity. The Oligocene Epoch, from about 34 to 23 million years ago, was a turning point. The terror bird family began to truly live up to its name with the emergence of giants that would have intimidated even the bravest prey. Paraphysornis, a Brazilian bird, was an absolute behemoth. It stood 4.5 feet tall and weighed a whopping 400 pounds. It outweighed the largest living bird today, the ostrich. Paraphysornis was built like a feathered tank, with robust bones that spoke of raw power. Paleontologists believe it hunted with kicks, slashes, and powerful jabs with its sharp beak. It was like a prehistoric version of mixed martial arts, with Paraphysornis as the undefeated heavyweight champion. But it wasn't just a brute. Like many terror birds, it likely possessed a level of intelligence that set it apart. Studies of terror bird brain cases suggest they had well-developed visual and auditory centers, keen senses that would have made them formidable hunters. As impressive as Paraphysornis was, it was merely setting the stage for what was to come. In the Miocene and Pliocene epochs, from about 23 to 2.5 million years ago, we find the true giants of the terror bird family. These creatures pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs. 3 names stand out: Titanis, Kelenken, and Brontornis. Each represents the pinnacle of the terror bird lineage. Titanis was the youngest and smallest of the trio, but also the most adventurous. While most terror birds stayed in South America, Titanis crossed the newly formed land bridge connecting North and South America during the Great American Interchange. It became the only large South American predator to successfully establish itself in North America. This bird lived in what is now the United States, including Texas, Florida, and California. Standing 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pliocene horse or ground sloth, used to saber-toothed cats and dire wolves, suddenly confronted by this alien predator. But Titanis was dwarfed by its cousins back in South America. Kelenken, named after a mythological Tehuelche spirit, stood a towering 9.8 feet tall and weighed around 550 pounds. This was a bird the size of a grizzly bear, with a head larger than that of a horse and a beak that could crush bone. I have been fascinated by the terror bird's skulls. Recent studies show that the larger species, like Kelenken, had a unique skull structure, setting them apart. This terror bird skull type gave them increased bite force. I can only imagine the power they possessed. This adaptation suggests that these giants could take down larger prey than we previously thought, maybe even some of the megafauna that roamed South America. But the title of the largest terror bird is still debated. Brontornis gives Kelenken a run for its money. While slightly shorter at 9.2 feet, Brontornis was built like a feathered bulldozer, potentially weighing up to 880 pounds. That would have made it not just the heaviest terror bird, but the heaviest carnivorous bird of all time and the fourth heaviest bird overall. Interestingly, Brontornis has been the subject of scientific controversy. Some paleontologists have questioned whether it was truly a terror bird or even a carnivore at all. They cite similarities in its toe claws to those of herbivorous birds. However, recent studies have identified features in Brontornis's vertebrae that are unique to terror birds, lending weight to its classification as a member of this fearsome family. Whether Brontornis was a terror bird or not, its massive size would have made it a force to be reckoned with. Its weight likely made it slower than its more nimble cousins, but what it lacked in speed, it made up for in raw power. I imagine Brontornis as the tank of the terror bird world, capable of steamrolling over any prey unfortunate enough to cross its path. While the giant terror birds like Kelenken and Brontornis might have relied on their size and power to dominate their environments, many of their relatives took a different approach. Speed, it seems, was just as important as size in the terror bird playbook. Studies of terror bird leg bones have revealed a structure remarkably similar to that of modern-day ostriches. Short thigh bones paired with elongated lower leg and foot bones. This adaptation is a clear indicator of high-speed running ability. Paleontologists estimate that many terror birds, including some of the larger species like Titanis, could have reached speeds exceeding 30 mph. That's faster than Usain Bolt, while standing twice as tall and weighing several times as much. But speed wasn't just about chasing down prey. For many terror birds, especially the smaller and medium-sized species, it was also a crucial defensive adaptation. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians, the ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terror birds versatile predators capable of adapting to a variety of hunting strategies. Smaller, faster species might have specialized in chasing down swift prey, like small mammals and reptiles, while the larger, more powerful species could have employed ambush tactics, or even taken on larger, more dangerous quarry. While their imposing size and fearsome beaks often steal the spotlight, the true power of terror birds lay in their highly developed senses. Recent studies of terror bird skulls and brain cases have revealed that these prehistoric predators were equipped with sensory capabilities that put them leagues ahead of many of their contemporaries. While terror birds might not have had eyesight quite as sharp as modern raptors like eagles or hawks, they were far from being visually impaired. Their eyes were well developed and positioned to provide excellent depth perception, a crucial advantage for any predator. But what really set terror bird vision apart was its versatility. These birds were equally adept at seeing in bright daylight and in the dim light of dawn and dusk, making them effective hunters around the clock. As for their hearing, the inner ear structure of terror birds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. Imagine a terror bird standing motionless in the prehistoric forests of South America, its head cocked slightly to one side. To a casual observer, it might appear to be resting or even dozing, but in reality, every fibre of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terror birds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall, and the reign of the terror birds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleobiogeographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terror birds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. The influx of new competitors from North America, while perhaps not the primary cause, would have added extra prez. Despite these challenges, the terror birds proved remarkably resilient. Recent discoveries have pushed back their extinction date much further than previously believed. For years, we thought they disappeared around 1 million years ago. But now we know that some smaller species survived until as recently as 96,000 years ago. Even more intriguing is the discovery of fossils attributed to an unidentified terror bird species dated to just 18,000 years ago. If confirmed, This would mean they survived almost until humans arrived in South America around 15,000 years ago. How close did humans come to encountering these feathered giants? What would such an encounter have been like? Could there be any truth to the legends of giant birds that persist in South American folklore? While direct interaction is unlikely, it's not far-fetched to think that stories of these creatures might have been passed down through generations. Other megafauna that coexisted with early humans, like woolly mammoths and giant ground sloths, left lasting impressions on human culture and mythology. This near miss between humans and terror birds is a poignant reminder of the incredible diversity of life that has existed on our planet. If they had managed to hang on for just a few thousand years longer, our understanding of the natural world might be very different today. This gradual increase in size can be explained, I believe, by the competition for food among large carnivores, which needed to eat more and gain more weight to compete for the apex predator position. The Nyandong tiger wasn't the only fearsome beast vying for dominance. It faced stiff competition from other carnivores, like the Smilodon, giant hyena, and dire wolves. The Smilodon, for example, is known for its long, slender canines that could reach up to 12 inches, capable of inflicting deep wounds on its prey. In contrast, the Nyandong tiger possessed more typical robust canines similar to modern tigers, ideal for crushing bone and delivering powerful bites, though less specialized for deep punctures, which was not always effective considering the enormous size of prey then. Although, when it comes to the matter of size, it appears that they were evenly matched as the largest species of Smilodon. The Smilodon populator weighed between 220 and 436 kilos and stood 120 centimeters tall, which is not that far off from that of the Nyandong tiger. A less formidable rival for the Nyandong tiger would have been the giant short-faced hyena, which stood about 90 to 100 centimeters at the shoulder and averaged 110 kilos in weight. However, a group of animals that the Nyandong would not have dared to infiltrate are the dire wolves. Although they had smaller jaws and weighed way less than the Nyandong tiger, they had a unique edge over it. And that is because they hunt in packs of more than 4 individuals. In contrast, as a solitary hunter, it would have been quite difficult for the Nyandong tiger to match that intensity when attacking prey. This factor placed it at a disadvantage in the competition for apex predator status. However, that was not the only thing the Nyandong tiger had to worry about when defending the apex predator title. Because around this time, the early humans were notably prevalent in Southeast Asia, as over 80 individual remains have been found in that region today. So it's likely that they would have crossed paths with the Nyandong tiger. It is easy to say that such encounters would have been unfavorable for the early humans, because when it comes to size, they stood very little chance against such predators. But saying that would be undermining their intelligence. Over time, early humans might have developed tools and strategies to fight back against the Nyandong tiger, forcing the tigers back to the open woodlands and allowing early humans to establish a foothold in the region. One thing about the open woodlands of Sunderland in the Pleistocene epoch is that it had numerous scattered trees and grasslands, which provided good visibility for stalking prey and offered a diverse array of herbivores, including many large species. However, hunting larger herbivores may not have been that successful, despite the Nyandong's enormous size. For instance, stegodons were massive proboscideans closely related to elephants, with some species reaching immense sizes. Even smaller species of stegodons would have dwarfed the Nyandong tiger. Stegodon sondi, for instance, is estimated to have weighed around 12.7 tons. Their thick and tough skin would have protected them from bites or claws. Then, the Nyandong tiger's best chance would be a scavenging opportunity or an attack on a vulnerable stegodon, like the young, injured, or isolated. Another example is the water buffalo, known as boobalus, which are renowned for their large size and formidable strength, with some species weighing over 1,000 kilos and moving in packs. So it would have been quite hard to face a herd of water buffalo, as their massive size, strong horns, and collective defense would overpower the tiger. The Nyandong tiger's only chance against such a colossal opponent would be to exploit their limited agility and target vulnerable areas through a surprise or flank attack. However, the Nyandong tiger succeeded more with other herbivores like Rusa timorensis, Malayan tapir, giant rats, gibbons, and wild boars. Despite its many difficulties, the Nyandong tiger still earned its place as one of the most impressive predators of all time. Since it hunted alone, its smart hunting skills and ability to target weaker prey, and even sometimes scavenge, shows us how adaptable and tough the beast was. This quality made it thrive for 1,000 years, until the extreme climate shifts of the Pleistocene epoch. These included periods of intense cold, with vast ice sheets locking up water, leading to lower sea levels, followed by warmer periods with melting glaciers and rising sea levels. As a result of this, Sunderland was fragmented into smaller islands, leading to the isolated populations of Nyandong tigers with limited resources and genetic diversity. From these isolated populations emerged smaller subspecies of tigers, such as the Sumatran tiger, Bali tiger, and Javan tiger. While climate change undoubtedly played a role, scientists proposed that the presence of early humans in Southeast Asia might have been among the reasons why the tigers went extinct. They likely caused increased competition for resources or potential conflicts that impacted the Nyandong tiger population. Other factors may have also contributed to their demise. But with limited fossil records, we are left with many unanswered questions. Imagine a cat the size of a bear, capable of leaping over a one-story building. That thought stayed with me for days when I first read about it. Not too long ago, in Earth's timeline, the Smilodon prowled our planet, the undisputed monarch of the Ice Age. You know it as the saber-toothed cat, though that name didn't come about easily. Rewind the clock about 160 years to Brazil. It's here that our tale begins, with a discovery that would perplex the scientific community. The first Smilodon remains weren't immediately recognized as belonging to a cat. In fact, the initial guess was way off. Based on some isolated cheek teeth that resembled those of modern hyenas, they dubbed this new find hyena neoga. Within a couple of years, new fossils emerged. Suddenly, scientists weren't just looking at a few teeth, but a veritable jigsaw puzzle of prehistoric proportions. Foot bones, skull fragments, and those canines, which seemed comically oversized, painted a very different picture. It became clear that this was no hyena, but a new genus of felid, massive in size and built like a prehistoric tank, far more robust than any modern cat. In light of this, a new name was in order: Smilodon populator. Smilodon meaning knife tooth, and populator roughly translating to the destroyer, a fitting moniker for a predator that redefined lethal. The scientific community dove headfirst into unraveling the Smilodon's family tree. Researchers currently place our knife-toothed friend in the extinct subfamily Machirodontinae, home to most of what we call saber-toothed tigers, though saber-toothed cats is more accurate, since these ancient felines aren't closely related to modern tigers or any living cats. In fact, their closest living relatives might be members of the Felinae subfamily, which includes our domestic kitties. Within the Machirodontinae, Smilodon found itself in an even more exclusive club, the Smilodontini, or, as some paleontologists call them, the dirk-toothed cats. This group is pretty exclusive, with only 5 known genera. As research progressed, scientists discovered that Smilodon wasn't a lone standout, but a prehistoric trio with 3 distinct members: S. gracilis, S. fatalis, and S. populator. If you found yourself face to face with any of these species, you probably wouldn't be too concerned with which one was about to turn you into lunch. But they did have their differences. S. gracilis appeared in North America about 2.5 million years ago, descending from an older genus called Meganterion. Next came S. fatalis, strutting onto the scene roughly a million years later. Last, S. populator made its grand entrance about 600,000 years after fatalis. S. gracilis, while no slouch, was the runt of the litter, weighing about the same as a modern jaguar. S. fatalis was a step up, matching an African lion in size, but packing on extra muscle, about 280 kilos or 620 pounds. But S. populator dominated them all, pushing the boundaries of felid physiology, with specimens estimated to have weighed in at 470 kilos or 1,040 pounds, about the same as a medium-sized polar bear. Interestingly, unlike many modern big cats, Smilodons didn't seem to be too hung up on gender norms. We're talking canines so long they stuck out way beyond the lower jaw, which was uncommon even among other saber-toothed cats. Smilodon's canines could grow up to 8 inches long. That's longer than many modern kitchen knives. They were precision instruments, shaped like deadly daggers with sharp points and smooth, narrow sides, designed to pierce deep into flesh with devastating efficiency. You'd expect a predator with teeth like that to have a powerful bite to match. But studies have shown that Smilodon's bite was relatively weak, about 4 times weaker than a modern lion's. So, how did it kill? One popular theory suggests Smilodon was the original ambush predator, hidden in dense vegetation, waiting for the perfect moment. Then, with a powerful leap, it pounced on its prey. Using those muscular forelimbs and grappling hook claws, it pinned down its victim. With precision, it sunk its saber teeth into the prey's soft underbelly, causing massive internal damage. But not everyone buys this gut-stabbing idea. Many researchers think Smilodon used its powerful build to quickly overpower its prey, then delivered a precise, lethal bite to the throat. Severe blood loss and suffocation. A quick end for its victims. Adding to this theory, Smilodon could open its jaw to an incredible 120 degrees, almost twice as wide as a human can manage. With a gape like that, pretty much every neck in the Ice Age would have been fair game. Smilodon wasn't just brawn and teeth. One of the strongest pieces of evidence supporting the idea that Smilodons lived socially comes from the La Brea tar pits in California. These California tar pits are a gold mine, preserving countless Ice Age animals that got stuck in the sticky asphalt. But most of the bones found in La Brea aren't from herbivores that got trapped, but from predators that got stuck trying to eat the trapped herbivores. Smilodon fossils are the second most common find in these pits, with over 166,000 bones attributed to it. This high number has led some scientists to suggest that Smilodon might have been a social animal. The reasoning goes like this. In modern cat species, the more social ones tend to be more responsive to distress calls. So, if one Smilodon got stuck, it might have called for help, attracting other members of its group who then also got stuck. Another fascinating clue pointing to Smilodon's possible social behavior is surprisingly touching, though in a prehistoric, slightly grim sense. Some Smilodon fossils show signs of severe injuries or disabilities that would have made hunting nearly impossible. Yet, these individuals survived well into adulthood. This has led some paleontologists to propose what they call pseudo-healthcare among Smilodons. The idea is that these injured individuals. It's a heartwarming, if speculative, image. The idea of Smilodon families looking after their own. Unlike most predators that can chomp down from the front, Smilodon was equipped with specialized slicing teeth called carnassials. These teeth, situated on the sides of the mouth, worked like biological scissors, shearing through meat with ease. To eat, Smilodon would have turned its head to the side, using these carnassials to slice off manageable chunks of meat, while its saber teeth stayed out of the way. If this eating style sounds familiar, that's because you might have seen it in action. Many modern cats and even other predators use a similar technique when tackling tough pieces of meat. It's a prime example of nature's problem solving. When life gives you saber teeth, you adapt your eating style accordingly. With its unique adaptations and hunting prowess, Smilodon carved out a vast empire for itself. Between its three species, it achieved a distribution across the Western Hemisphere that would make any modern predator green with envy. In North America, Smilodon gracilis and Smilodon fatalis roamed from coast to coast, reaching as far north as Alberta, Canada. Meanwhile, in South America, Smilodon fatalis and Smilodon populator established a domain stretching all the way down to Patagonia. But Smilodon wasn't just geographically widespread. It was also adaptable. Fossils have been found in a diverse array of environments, from grasslands and plains to woodlands and closed forests, from savannas to subtropical forests, and even mammoth steppes. This adaptability allowed Smilodon to live alongside a veritable who's who of Pleistocene megafauna. We're talking about a world where you might encounter short-faced bears, proboscideans, ground sloths the size of cars, armored glyptodons, the rhino-like toxodon, camels, deer, horses, bison, and even terrorbirds. It was like a real-life version of the ice levels in every video game, but with 100% more lethal prehistoric cats. But there was one more species that Smilodon encountered in its twilight years, one that would change the face of the planet forever: humans. It's believed that our ancestors might have first crossed paths with Smilodon around 25,000 years ago. Now, imagine being one of those early humans, armed with nothing but primitive tools, coming face to face with a saber-toothed cat. The relationship between humans and Smilodon was likely a tense one. After all, we were competing for many of the same food sources. And unfortunately for our ancestors, by the time humans arrived on the scene, only the larger S. populator and S. fatalis remained. Talk about bad timing. Given that Meganterion, the possible predecessor of Smilodon, was known to occasionally prey on Homo erectus, it's not a stretch to imagine that Smilodon might have considered early humans as potential prey too. But don't feel too bad for our ancestors. Humans are nothing if in 2021 something extraordinary surfaced. A petroglyph seemingly depicting humans observing a Smilodon from a safe distance. I can only imagine what it must have been like, our ancestors sharing the landscape with those magnificent, terrifying creatures. But, of course, the coexistence didn't last. The youngest remains of both Smilodon fatalis and Smilodon populator date back roughly 10,000 years. Around the same time, humans were figuring out agriculture. The reason for their extinction continues to be debated among paleontologists. Some argue that humans played a significant role through direct competition or by altering habitats, like starting fires. Others are less convinced. The more widely accepted theory points to the broader Quaternary extinction event, a period of significant climate change that led to the disappearance of many large animal species in North and South America. As the megafauna that Smilodon relied on for food began to die out, the saber-toothed predator found itself in an increasingly precarious position. It's a cruel irony that the very adaptations that had made Smilodon such a successful hunter of large prey ultimately became a liability. Specialized to take down giants, it struggled to adapt to a world where those giants were disappearing. It was, in essence, too good at what it did. And when the world changed, it couldn't change with it. The extinction of Smilodon marked not just the end of a species, but the end of an era. It was the last of the saber-toothed cats, not just in the Americas, but worldwide. With its passing, a lineage that had dominated the planet for over 20 million years came to an end. Its legacy, however, still resonates in museum exhibits, in our imaginations, and as a reminder of the fragile balance between species and their environments. As we face our own period of rapid change, the lesson of Smilodon is clear. Survival requires adaptation. Most apex predators face a fundamental limitation. They're trapped in one environment. Lions rule the savanna but are helpless in water. Great whites dominate the ocean but can't set a fin on land. Even T-Rex, for all its might, was confined to dry ground, forced to watch as prey slipped into rivers and lakes beyond its reach. For over a century, paleontologists assumed the greatest hunters were strictly terrestrial. Then, one discovery shattered that belief overnight. Its name was Spinosaurus aegyptiacus. Longer than a bus, armed with the skull of a crocodile and the body of a streamlined aquatic hunter, this was no ordinary killer. This was the nightmare that redefined what it meant to be an apex predator. a monster that could rival, and in many ways surpass, even T-Rex itself. The first thing that strikes you about Spinosaurus isn't its length, though at 50 to 59 feet, 15 to 18 meters, it dwarfs even the largest T-Rex specimens. It's not even the massive sail rising from its back, like some prehistoric fin. For anything living in those rivers, the nightmare was the same. The faint ripple at the surface, the sudden silence, and then the 7-ton shadow sliding in after you. And while most large theropods had relatively small forelimbs, Spinosaurus possessed powerful, elongated arms ending in massive claws. These weren't vestigial appendages. They were additional weapons, perfectly positioned for grabbing prey, maintaining balance in water, or delivering killing blows. The creature could literally embrace its victims to death. And then there's the sail, rising up to 7 feet, 2.1 meters, above its spine. This massive dorsal fin dominated Spinosaurus's silhouette like the warning flag of death itself. Scientists debate its exact function: thermoregulation, display, fat storage for surviving dry seasons. But its psychological impact is undeniable. Picture this nightmare rising from murky water. First, the elongated snout breaking the surface. Then those cold, reptilian eyes. And finally, that towering sail cutting through the air like the dorsal fin of some impossible shark. Imagine the terror of being a fish in the rivers of Cretaceous Africa. Generations spent honing instincts to recognize danger. The shadow of a pterosaur, the ripples of a crocodile, subtle shifts in current. All those hard-won adaptations rendered useless by a predator unlike any other. What makes this ecosystem so remarkable isn't just the individual creatures, but how they managed to coexist in what might have been the most dangerous environment in Earth's history. On land, giants like Carcharodontosaurus patrolled the inland areas, while Spinosaurus dominated the waterways. And Sarasuchus, the 40-foot supercroc, competed directly with it for aquatic hunting grounds. Mid-sized hunters such as Rugops cleaned up Spinosaurus leftovers, while swift predators like Deltadroius and Bahariosaurus used speed and specialized tactics to carve out their place. Herbivores somehow survived this gauntlet: Ouranosaurus, Rebachiosaurus, and the colossal Paralititan. The waters themselves were far from safe, filled with monstrous prey like Entroprist, Morsonia, Chelanths, Lepidotes, and lungfish. Every species in this ecosystem lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink, and aquatic prey developed increasingly tough defenses. The last Spinosaurus died approximately 94 million years ago. But the questions this creature raises about predation, dominance, and the very limits of survival continue to ripple through scientific understanding. When we think of prehistoric apex predators, our minds often drift to the iconic Tyrannosaurus rex, or the fearsome megalodon. Yet, lurking in North America's ancient past was a predator so extraordinary it could make today's largest wolves look like lapdogs. Today's grey wolf may hold the crown as the largest living canid, reaching weights at 65 kilograms or 143 libras. But rewind to the Miocene epoch 20 to 5 million years ago and the game changes. A new apex predator emerges. Meet Epicon, a colossal predator so fearsome it could rival a lioness in size and had jaws powerful enough to outmatch a grizzly bear. In simpler terms, this was a dog that could eat a lion. Its name says it all, Epicion, meaning more than a dog. Because calling it just a dog doesn't do it justice. The story of Epicon's discovery represents one of paleontology's most intriguing progressions, from misidentification to revelation. Over 160 years ago, in the fossil-rich sediments of Nebraska, scientists unearthed the first fragments of what would later be recognized as the largest canid species ever to walk the Earth. The initial discovery consisted of a fragmented lower jaw. While obviously from a large carnivore, it provided only hints of the creature's true nature. The jaw's wolf-like characteristics led early paleontologists to classify it as a subgenus of Canis, the genus that includes modern wolves, coyotes, and jackals. This classification seemed logical at the time, given the limited fossil evidence. However, as more complete specimens emerged from North American fossil beds throughout the following decades, a much more complex picture began to emerge. The discovery of complete skulls proved particularly revolutionary. These specimens revealed that while certain features resembled those of wolves, others were startlingly different. There's a skull that's been puzzling paleontologists, one that seems to belong to something more than just dog. Its premolars are enlarged, its cranial structure robust, almost like a lion or hyena. It's an unusual combination, and the answer, as it often does, lies in the details. These features point to the Borophaginae, a distinct group within the canid family. They're one of the most successful, yet somehow least known, branches of the entire canid family. Imagine 66 known species within this group alone. They were defined by their powerful teeth, shortened but deep jaws, and a fifth toe, a feature lost in many modern canids we see today. For over 15 million years, these Borophaginae dominated North America, evolving into an array of forms. Some were fox-sized, others rivaled the size of modern grey wolves, and among them emerged Epicion, the ultimate bone-crushing dog, a name that literally translates to more than a dog. Recent studies comparing modern canids have helped place Epicions within the larger family tree. The Borophaginae were a highly specialized branch, following a unique evolutionary path distinct from the line that led to modern wolves and dogs. This explains Epicion's unusual features and, perhaps, its eventual disappearance. Within the Epicion genus, 3 distinct species arose to fill different ecological niches: Epicion saevus, Epicion haydeni, and Epicion elodontoides. While all were impressive predators, they differed in size and build. The smaller species, saevus and elodontoides, were more gracile, built for agility and speed. Still, these smaller species typically weighed twice as much as a modern German Shepherd. But it was Epicion haydeni that truly pushed the boundaries. Adults routinely reached lengths of 2.4 meters, nearly 8 feet, rivaling a grizzly bear. They stood 90 centimeters, or 35 inches, at the shoulder, about the height of a wild deer. These massive animals weighed between 125 and 170 kilograms, making them heavier than modern leopards, and comparable to large jaguars, or even a medium-sized male lion. What's intriguing is that Epicion haydeni exhibited significant size polymorphism, variation in size among individuals of the same species. Some specimens reached weights of around 170 kilograms, making them the heaviest known canids to ever exist. But its size wasn't even its most remarkable feature. It was its bite. Pack hunting, in this context, would have been particularly useful, allowing them to surround and overwhelm prey that might have otherwise escaped. One of Epicion's most remarkable adaptations was its ability to process and digest bone, setting it apart from most other large carnivores. Its specialized premolars and thickened molars, with their short, pyramid-like shape and wide bases, closely resembled those of modern hyenas. It's a fascinating example of unrelated species developing similar adaptations to exploit the same ecological niche. Recent analysis of fossilized feces associated with Epicion has revealed high concentrations of processed bone material, confirming this behavior. This adaptation would have provided several advantages. First, it allowed them to extract maximum nutrition from their kills by accessing bone marrow. Second, it potentially reduced competition with other predators by allowing them to utilize parts of carcasses that others couldn't process. This ability would have been particularly valuable during periods of scarcity. The Miocene epoch was characterized by significant climate fluctuations, and during times when prey was scarce, the ability to fully utilize every part of a carcass would have provided a crucial survival advantage. The success of Epicion is evident in its widespread distribution across North America. Fossil remains have been discovered in more than 10 different US states and parts of southern Canada, indicating a remarkable ability to adapt to various environments. They thrived in a diverse array of habitats, from woodlands and savannas to grasslands and wetlands. Recent discoveries of Epicion remains in cave systems and edge environments suggest that they were not only adaptable, but potentially strategic in their habitat selection, preferring areas that provided both hunting opportunities and shelter. Their ability to process a variety of foods likely contributed to this ecological flexibility. While primarily carnivorous, the structure of their teeth suggests they could also process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The ultimate disappearance of Epicion from the fossil record has long intrigued paleontologists. Early theories suggested that competition from newly arriving big cats led to their extinction. However, this hypothesis has largely been discounted. Current evidence points to climate change as the primary driver. The late Miocene saw significant global cooling and increased aridity, leading to fundamental changes in North American ecosystems. This transformation would have affected not only the types of prey available, but also hunting strategies. Epicion's specialized adaptations may have become disadvantageous, as prey species became faster and more adapted to open environments. Unlike their more generalized relatives, which gave rise to modern wolves and other canids, Epicion's extreme specializations may have limited its ability to cope with these changing conditions. I'm still struck by the first time I saw the Dion of Ankylosaurus magniventris, a fused lizard with a great belly. It was a bizarre blend of armor plates, robust bones, and those distinctive teeth, all conspiring to our understanding of dinosaur defense. This wasn't just a milestone for paleontology. It was a window into the intricate design of one of nature's most formidable creatures. The name itself, Ankylosaurus, meaning fused lizard, hints at its remarkably fortified skeleton. The magniventris part, translating to great belly, highlights its distinctively broad midsection. In 1906, Barnum Brown, a renowned paleontologist from the American Museum of Natural History, led an expedition through Montana's Hell Creek Formation. Among the layers of Cretaceous sediment, he unearthed an assortment of fossils that initially perplexed him. These weren't the slender, elongated bones of theropods or the broad frills of ceratopsians. Instead, Brown had uncovered fragments of bony plates, uniquely shaped teeth, and vertebrae that hinted at a heavily armored animal. Early interpretations were cautious, of course. Brown initially speculated that the bones might belong to a previously unknown type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens, each shedding light on the creature's physical characteristics. The painstaking process of piecing together its skeletal framework was akin to assembling a prehistoric jigsaw puzzle, with every discovery adding a layer of complexity to its story. What made Ankylosaurus magniventris stand out was not only its robust anatomy, but also its ecological implications. Fossils of Ankylosaurus were found in association with remains of plants, indicating the lush environments it inhabited. Over the decades, advances in paleontological techniques, including CT scanning and isotope analysis, have allowed scientists to reconstruct its appearance and understand its lifestyle in remarkable detail. From the armored plates that defined its body to the distinctive club at the end of its tail, Ankylosaurus stood as a creature that epitomized nature's ingenuity. What made this discovery particularly groundbreaking was that it didn't just represent a new species. It became the cornerstone of an entirely new group of dinosaurs, the Ankylosauria. These animals, belonging to the larger clade Ornithischia, were characterized by their extensive armor plating and herbivorous lifestyle. This seemingly counterintuitive design actually represented a remarkable feat of natural engineering. The hollow structure created a dome-like formation that distributed impact forces more effectively than solid plates would have, similar to how modern motorcycle helmets use their curved design to protect riders. This adaptation made the armor particularly effective. The tail club of the Ankylosaurus wasn't just a simple bony growth. It was a precisely engineered weapon, nature's way of saying, "Don't mess with me." Recent CT scans of these tail clubs have revealed an intricate internal structure, optimized for both strength and swing speed. The club itself was composed of two large osteoderms at its core, complemented by smaller ones at the tip and along the midline. All of this was supported by a framework of highly modified vertebrae, specifically adapted to handle the stresses of high-speed impacts. I find the measurements staggering. Specimens show the club could reach over 50 cm in width and weighed around 23 kg. But these numbers only tell part of the story. The real marvel was in the biomechanics. Advanced computer modeling has shown that large individuals could generate impact forces exceeding 20,000 newtons. Even more remarkably, they could achieve swing impulses of up to 4,800 newtons per second. The association of Ankylosaurus fossils with specific types of vegetation has led researchers to hypothesize that they may have helped disperse seeds, inadvertently promoting plant diversity. Seasonal changes would have impacted the behavior of Ankylosaurus. Fossil evidence indicates that some regions experienced dry and wet seasons, influencing the availability of food resources. Ankylosaurus may have adapted by modifying its diet or undertaking small-scale migrations to follow vegetation growth. The robust construction of its body, coupled with its ability to consume tough plant material, would have allowed it to survive in less than ideal conditions. The coexistence of Ankylosaurus with large herbivores like Triceratops and Edmontosaurus, as well as apex predators like Tyrannosaurus rex, paints a vivid picture of its ecological niche. While Ankylosaurus was not the most numerous dinosaur in its ecosystem, its defensive adaptations end its survival alongside fierce competition. Its presence in these environments exemplifies the Ankylosaurus. I've always been fascinated by its sensory capabilities, almost as much as its famous armor. Imagine having a sense of smell so powerful that it rivals modern reptiles and mammals. Fossil evidence shows that its olfactory bulbs, the part of the brain that processes smells, were unusually large. Recent imaging of Ankylosaurus skulls reveals intricate nasal passages that likely enhanced its sense of smell and helped regulate its body temperature. These convoluted nasal cavities created a large surface area, allowing it to cool or warm incoming air, an adaptation that would have been essential for the varied climates of the late Cretaceous period. Vision and hearing also played a role in the Ankylosaurus's survival. Its eyes, though small, were positioned on the sides of its skull, providing a wide field of view. This would have allowed it to detect predators approaching from almost any direction. This peripheral vision, combined with its heightened sense of smell, would have made it difficult for ambush predators like Tyrannosaurus rex to catch it off guard. While direct evidence of its auditory capabilities is sparse, the structure of its inner ear suggests that Ankylosaurus could detect low-frequency sounds. These sounds could have been useful for sensing the movements of large predators or communicating with others of its kind. It's an intriguing thought. The Ankylosaurus using its senses in conjunction with its defenses. Its acute sense of smell and hearing could have allowed it to detect a predator's approach early enough to position itself defensively, presenting its armored back and tail club as a warning. These advanced sensory capabilities underscore just how specialized and well-equipped the Ankylosaurus was to navigate its dangerous world. Of course, the reign of the Ankylosaurus, along with other non-avian dinosaurs, came to an end during the KT extinction event about 66 million years ago. But its legacy lives on, especially in our understanding of natural defense mechanisms. The Cretaceous period was truly an era of titans. Not only did it produce the largest terrestrial predator, but also the largest land animals ever known. It was a monster mash of epic proportions. While dinosaurs dominated, other species also reached massive sizes, including flying reptiles and marine lizards. Around 82 million years ago in North America, we saw the emergence of Deinosuchus, the largest crocodilian in Earth's history. Its name translates to terrible crocodile, and it was first discovered in the 1850s when large, distinctive teeth were unearthed in North Carolina. Initially, these teeth were mistaken for those of a pliosaur, a type of marine reptile, which led to considerable confusion among paleontologists. But they soon realized that this creature was something else entirely. The sheer size and unique characteristics of the teeth didn't align with known marine reptiles, prompting a deeper investigation. The journey to accurately identify this gigantic predator was significantly advanced by Dr. Joseph Leidy, a leading paleontologist of the 19th century. His meticulous examination and publications played a pivotal role in re-evaluating these remains. Leidy's research corrected the initial misclassification, revealing that the teeth belonged to an entirely different kind of prehistoric creature. The newly proposed classification reflected the immense size and formidable presence of this crocodilian, which was aptly named Deinosuchus hatcheri, in honor of John Bell Hatcher, a distinguished paleontologist. The idea that a crocodilian could outweigh most dinosaurs, that's something that has always captivated me. When the first remains of Deinosuchus were found, initial estimates suggested adults could reach almost 50 feet in length and weigh over 10 tons. While those numbers were a bit exaggerated, the truth is still astonishing. Unlike some species whose size gets downgraded over time, Deinosuchus has held on to its colossal reputation. There are 3 recognized species: Deinosuchus hatcheri, rugosus, and riograndensis. The hatcheri species, discovered in North Carolina, gave us critical early insights into the genus. The rugosus, found mainly in Montana, had a more robust build, maybe an adaptation to different prey or conditions. And then there's the riograndensis, uncovered in Texas, which grew even larger than its eastern relatives. The Texas finds were more plentiful, giving us a clearer picture of how these giants lived. Paleontologists now believe that the average adult Deinosuchus made between 26 and 33 feet long, weighing between 2.5 and 5 tons, more than twice the size of a male hippo. And some grew even larger than that. Even with the initial overestimates corrected, the reality of their size remains impressive. The riograndensis species really stands out. Detailed studies of remains found in Texas suggest the largest individuals could reach lengths of up to 39 feet and weigh around 8.5 tons. That would make them not only the largest crocodilians ever, but also heavier than most dinosaurs, save for Tyrannosaurus rex. Paleontologist Thomas Lehman, who studied the Texas fossils extensively, offered fascinating insights into their biology and growth. His research showed that the largest specimens had growth rings in their osteoderms, much like tree rings, which told us a lot about their age and growth rates. The largest riograndensis showed signs of rapid growth as juveniles, followed by a more gradual growth into adulthood. This suggests environmental factors, like food and climate, played a big role in how large they could get. With its brain case and overall appearance, Deinosuchus was strikingly similar to modern alligators, with a body and snout that resembled these contemporary relatives. But beyond this general likeness, Deinosuchus had a unique skull shape, unlike any other crocodilian, living or extinct. The skull could measure up to 5.6 feet in length, comparable to that of an adult Spinosaurus. Despite its size, studies show that its bite force was, surprisingly, somewhat modest. These fossilized remains contain fragments of dinosaur bones, fish scales, and turtle shells, giving us a snapshot of what it consumed. Dr. Karen Chin, a specialist in coprolite studies, has emphasized how important these findings are. The diverse prey items found in Deinosuchus remains highlight its opportunistic feeding behavior. It seems this ancient predator consumed a wide range of animals, from large herbivorous dinosaurs to smaller aquatic creatures. Deinosuchus is thought to have used ambush tactics to capture its prey, using its massive size and crushing bite to inflict fatal injuries. Like modern crocodiles, this giant predator likely employed a death roll maneuver to enhance its hunting. This technique involves grabbing prey and then rapidly rotating, using the predator's body weight and momentum to incapacitate and dismember it. Reconstructing the hunting methods of Deinosuchus involves analyzing fossil evidence and comparing it with the behavior of modern crocodilians. The robust anatomical features of Deinosuchus, including strong neck muscles and a sturdy body, support this hypothesis, suggesting it was a highly effective predator in its ancient ecosystem. Deinosuchus experienced a slow growth rate, as evidenced by growth rings on its osteoderms. These rings indicate that it took around 35 years to reach full size. Despite this long maturation period, juvenile Deinosuchus were still formidable predators, sporting considerable size and powerful bites even at a young age. This interaction could suggest a complex predator-prey dynamic within its ecosystem, influencing the behavior and distribution of various species. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures. It coexisted with herbivorous dinosaurs like Anodontosaurus, Griosaurus, Cosmoceratops, Eutriceratops, and many others. Bite marks on the bones of hadrosaurs and other dinosaurs provide clear evidence of its predatory behavior. Deinosuchus's presence likely impacted the distribution and behavior of these animals, asserting itself as an apex predator in its habitat. Despite its dominance, Deinosuchus vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear, though climate changes, sea level fluctuations, and competition with emerging predators are potential factors. Its extinction marked the end of an era, but the fossil remains of Deinosuchus continue to provide valuable insights into the life and ecosystems of the late Cretaceous period. In the world of big cats, the tiger, lion, and jaguar have always fought for supremacy, each vying to be the ultimate apex predator. But there's one ancient beast that towers above them all, the American lion. This was no ordinary feline. It was the largest to ever walk the earth. Imagine a creature so massive that some individuals weighed as much as an adult brown bear, easily dwarfing today's biggest lions. This isn't just another big cat. It's a legendary predator that dominated its world like no other, leaving modern felines in the dust. The story of this magnificent creature's discovery begins in the humid lands of Mississippi during the early 1800s. When paleontologists first unearthed fragments of its skull, they initially believed they had found remains of an unusually large domestic cat, placing it in the genus Felis. This classification, however, would prove to be just the first chapter in a much longer story of scientific discovery and reclassification. As more specimens emerged from the Earth, scientists quickly realized they were dealing with something far more impressive: the sheer size and distinctive features. Modern science has a way of reshaping our understanding of prehistoric life. I've found the story of the American lion to be a perfect example. This massive predator, much like the recently reclassified dire wolf, wasn't exactly what we first thought it was. Despite its lion-like features, detailed anatomical studies revealed crucial differences that set it apart from modern lions. One of the things that prompted researchers to reclassify the species under the genus Panthera, home to today's most powerful big cats, the lion, tiger, jaguar, leopard, and snow leopard. Initially dubbed Panthera leo atrox, it was thought to be merely a subspecies of the modern lion, earning it the popular name American lion. But these distinctions, a more robust build, proportionally longer limbs, and most notably the absence of a prominent mane in males, led to its reclassification as its own species, Panthera atrox, the cruel panther. DNA analysis has shown that it emerged from an isolated population of cave lions that became trapped south of the North American ice sheets approximately 340,000 years ago. This separation occurred during a crucial period of the Pleistocene epoch, leading to rapid adaptations to North American environments. While modern lions are indeed their closest living relatives, the last common ancestor between these species lived somewhere between 500,000 and 1.9 million years ago. It's a testament to how quickly changes can occur under the right conditions. The sheer size of the American lion sets it apart from any feline, living or extinct. On average, these beasts were about 25% larger than today's African lions. But this statistic only tells part of the story. Male American lions typically weighed between 351 kg 774 lb and 420 kg 930 lb, already making them substantially larger than any living big cat. However, the most impressive specimens, discovered in 2012, have been estimated to weigh an astounding 523 kg 153 lb, equivalent to the weight of 8 adult humans combined. To put this in perspective, even the largest recorded Siberian tigers, which are the biggest living cats today, rarely exceed 300 kilos, 660 lb. The American lion's only real competitor for size was the equally impressive Smilodon populator, which could reach weights of up to 470 kilos, 1,040 lb. However, the discovery of those exceptionally large American lion specimens in 2012 firmly established Panthera atrox as the heavyweight champion of the feline world. What makes the American lion particularly remarkable is that, despite its enormous size, it maintained the agility and speed characteristic of big cats. Conservative estimates suggest it could reach speeds of over 30 mph, 48 km/h, faster than any human athlete, and comparable to a charging warthog. This combination of size and speed would have made it an extraordinarily effective predator. The hunting strategy of the American lion likely relied heavily on ambush tactics. This conclusion is drawn from both its anatomical features and the hunting behaviors of its modern relatives. Its robust bone structure and powerful muscles would have allowed it to quickly overwhelm large prey, while its long legs provided the burst speed necessary for successful ambush attacks. Fossil evidence provides compelling insights into its hunting capabilities. Their smaller pride size, combined with their larger individual mass, meant each pride needed to bring down fewer but larger prey animals to sustain themselves. Perhaps most fascinating is the evidence of their den sites discovered in caves across the American West. These sites, particularly those found in the Grand Canyon region, show signs of multi-generational use, some caves bearing marks of occupation spanning thousands of years. The walls of these dens often bear deep scoring marks from claws, a behavior seen in modern big cats, but at a scale that dwarfs anything in the present day. Some of these marks are placed over 3 m high on cave walls, providing tangible evidence of their incredible reaching height when standing on their hind legs. These locations have yielded another surprising discovery: collections of bones from juvenile American lions of varying ages, suggesting that, like modern lions, they had developed sophisticated parenting strategies. Unlike solitary big cats such as tigers, American lions appear to have invested heavily in cooperative cub rearing, a social adaptation. The American lion's bite was something to behold. I remember being stunned when I first read about it. Nearly 3 times stronger than a modern lion, 6 times more powerful than the Smilodon. That thick, powerfully built skull could generate a bite force of 1,800 pounds per square inch. And those canine teeth could reach lengths of 4 inches. Fossil evidence from the La Brea tar pits gruesomely demonstrates the effectiveness of this bite. There were remains of a grey wolf with its right femur completely severed, not by scavenging, but by a single bite from an American lion. The wolf actually survived the encounter, evidenced by signs of healing. It's a stark illustration of the devastating power these cats possessed. What I find truly intriguing is the apparent intelligence of the American lion. They had a notably large brain case, suggesting significant cognitive capabilities. When you combine this with the problem-solving abilities seen in modern panther species, it indicates that the American lion was likely a highly intelligent predator. This intelligence is particularly evident in their interactions with natural hazards. Despite being one of the most common large carnivores of their time, they're surprisingly underrepresented in tar pit fossil deposits, compared to other predators like dire wolves and smilodons. This pattern suggests they were better at recognizing and avoiding these natural traps, demonstrating a level of environmental awareness that set them apart. Their range extended across much of North America, from Alaska to central Mexico, adapting to various environments from open grasslands to semi-forested regions. They shared their territory with an impressive array of Pleistocene megafauna, including woolly mammoths, mastodons, giant ground sloths, and early human populations. Recent studies of cave paintings and other archaeological evidence suggest that these massive cats left a lasting impression on human cultures, potentially influencing early American art and mythology. The end came for the American lion approximately 12,800 years ago, coinciding with a broader extinction event that claimed many of North America's large mammals. This timing aligns with both significant climate changes at the end of the last ice age and the expansion of human populations across the continent. The exact cause of their extinction remains debated, but it was likely a combination of these factors. Changing environments, reducing prey availability, and increasing human prey may have pushed these magnificent predators past their breaking point. Now I want to turn to another prehistoric ruler, this one of the sky. Imagine a creature soaring over the land, an enormous beast with massive wings casting a huge shadow below. This is Quetzalcoatlus. Quetzalcoatlus belonged to the Azhdachidae family of pterosaurs, known primarily from the late Cretaceous period. Discovered in 1971 in Texas, the original specimen included portions of an arm and wing finger. The paleontologist who discovered it realized it was something truly monstrous. He was so mesmerized by its size that he named the creature after a mythological Aztec serpent god, and also named it after an aircraft manufacturing company. And so, Quetzalcoatlus northropi, the conqueror of the skies, was named. It's often said that Quetzalcoatlus is the biggest pterosaur and the largest flying animal in history. But despite its enormous size and cohabitation with the Tyrannosaurus, little is known about its biology. Its wingspan was first estimated to be wider than an F-22 fighter plane, but paleontologists today believe it probably grew to be between 33 to 39 feet wide, which is still larger than an F-16. And it stood roughly the same height as a giraffe on the ground. Some researchers believe it may have weighed as much as 250 kilograms, very close to a grizzly bear. For years, Quetzalcoatlus was known as the largest pterosaur to ever exist. However, recent discoveries of larger species have challenged it in size and weight. One such giant is Hatzegopteryx, hailing from Europe, that possessed a similar wingspan but was larger in weight. Quetzalcoatlus. Even the name sounds like something out of a dream, a whispered legend from a time when giants walked the earth and ruled the skies. I find myself returning to this creature again and again. Imagine a reptile with the wingspan of a small plane, soaring over the landscape. It had an extraordinary metabolism to support its way of life, resembling other pterosaurs. For a long time, scientists believed it was cold-blooded, like other reptiles. But now, the evidence points to Quetzalcoatlus being warm-blooded, an active animal. Warm-blooded or cold, it certainly wasn't winning any beauty contests. It had a long, pointed beak, similar to a modern stork, but without the hooked tip. Excavations have revealed that the skull of Quetzalcoatlus northropi was larger than that of Quetzalcoatlus lawsoni, confirming that northropi was the larger of the two species. Intriguingly, it could rotate its head 180 degrees, a remarkable adaptation that would have improved its ability to locate prey and watch out for ambushes. This head rotation led some to theorize that Quetzalcoatlus may have lived and hunted primarily on the ground, simply because it seemed too heavy to fly. This theory never really took off, so to speak. The unearthed bones suggest that Quetzalcoatlus had very light, almost potato chip-like bones, which may have made flight easier than we initially imagined. This discovery then led to a new question. How did it even take off? Many theories suggest the enormous reptile leaped into the air by flapping its wings, or perhaps even lurching forward on its wingtips, like a vampire bat. It may have even crouched before launching itself 8 feet into the air, giving it the space to spread its wings. Its secret weapon? Those strong hind legs that supported the massive push required to jump. One study suggests that Quetzalcoatlus was a remarkable flyer, engaging in brief powered flights before gliding, reaching a top speed of 80 mph, which it could sustain for days. This would have given it an extraordinary range. Despite its bulk, Quetzalcoatlus' torso was extremely dense and full of massive muscles. These giants could take off with a single leap and maintain altitude with just a few flaps. After launch, they could probably fly non-stop for thousands of kilometers, simply flapping rarely to maintain altitude and guide their course. The short wings were made of tightly packed muscle fibers that end flexibility and strength, allowing precise adjustments in the air. The extraordinary flight techniques inspired a mission to construct a model flying machine to test flight simulations. It was the size of Quetzalcoatlus lawsoni, with a basic computer acting as an autopilot. The model demonstrated the effectiveness of the experiment by soaring and flapping its wings as it moved through the air. Quetzalcoatlus and other Azhdarchids had hind limb proportions more similar to modern running mammals than to their smaller cousins, implying they were uniquely suited to a terrestrial lifestyle, even though they were quadrupeds when on the ground. This has led scientists to study the lifestyle and feeding habits of these creatures. It's widely accepted that Quetzalcoatlus was a carnivore, although its exact diet remains a mystery. Douglas Lawson, who first discovered Quetzalcoatlus, initially suggested it scavenged on the carcasses of titanosaur sauropods, much like a marabou stork.